Hello everyone, this is Brian Nissen from QTS Medical Device Outsourcing, here with another 3 quick tips. So today's 3 tips are all about package testing. We're going to go over 3 of the very basic ways that sterile barriers can be tested and what those ways are good for and what they're not so good for. So first method is tensile testing. Tensile testing is used on a package to test the strength of the bond between the 2 layers of the package. So if it's the tray and the lid, or the two webs of a pouch, it's that seal as you create it. It's a measurement of the strength of that bond. So the way that you generally do this is you'll cut a 1-inch wide strip out of the sealed area of the package, and then you'll put it into a tensile testing piece of equipment where you clamp it in the lower grip and the upper grip, and then record the tensile strength as that package is pulled. You could do the average strength, you could do the peak strength. There's different methods, and I advise you check out the standards on the testing if you want to learn more. But ultimately, this produces a variable result. It's a number of pounds per inch of seal width. This is really good for measuring a process to see whether or not it's staying within statistical control. Generally, manufacturers like to put a specification on this seal strength, but what I find it is most useful for is to see whether or not your manufacturing process has shifted. So periodically during a manufacturing run, you'll take a sample and bring it over to your tensile testing equipment and peel test it. Something that tensile testing is not very good at is detecting non-integral seals. I mean, as you can see from the tensile testing example we just did, you could have a wrinkle in that seal or a small channel or something like that, and it wouldn't necessarily show up in a change in the tensile strength of the package. Okay, test method number 2, we're going to talk about dye penetration testing. Dye penetration testing is where you will open up a small part of your package and inject a dye. Now this dye is primarily water, but it also has a little bit of powdered dye solution in it, and also a surfactant. The surfactant lowers the surface tension of the solution so that it'll shoot through any gaps in the package or any gaps in the seal. And so what we'll do is we'll open it up and we'll inject the dye into our package so that it's about just a little bit covering the entire seal area, and then we'll inspect it. Now sometimes with these porous packages like the Tyvek we have here, it'll start to wick into the seal area. This is not a reject. Now if there's a channel through your seal, within the first second or 2 of the inspection, you'll see that dye just go shooting through. Dye testing is really good for inspecting a sealing process output for integrity. You can tell whether or not your sealing process is making fully formed seals. You can see though, it's not testing the entire package. It's testing just that seal area. There are methods for using dye penetration to test an entire package, but it's not the best. Really good thing though is because the surfactant lowers the surface tension, it can detect very, very small channels in your seal, down to 2/1000th of an inch. That's thinner than a piece of paper. All right, now method number 3 is bubble leak testing. Again, there's many ways to perform this test, but we're doing what is a very common method. And so where we take our package and we'll put a hole into it, we'll put our test equipment onto it and raise it to a set pressure determined by a positive control. And then we'll take that and submerge it underwater and inspect for leaks. So it's kind of the same method that you would use to find a leak in maybe a bicycle tire. And so you can see for a package that's integral, this is testing the entire package, and if we have a leak, you'd see a stream of bubbles coming out of it. Bubble leak testing is very good for entire package testing. So it's if you do a package validation and you want to see whether or not during your distribution simulation, if you developed a pinhole leak, this is an excellent method for determining if you have integral sterile barriers. It's not quite as good at detecting very, very small channels in seals because the sensitivity of the test is only about 10/1000ths of an inch. But for certain types of packages, like this foil package, I could not possibly do a dye test because I can't see through either side of it. All right, thank you everyone. This has been another 3 Quick Tips with Brian Nissen, Project Engineering Manager from QTS Medical Device Outsourcing. Have a great day.